Hello, good afternoon. Thanks for coming back, or welcome if you weren't here for the first part. We're in the second part of the Herbarium Procedures and Technique session. We have 6 lectures this session. And just a reminder for our workshop tomorrow, which is in this room at 9 a.m. If you follow the QR code, there's a Mentimeter poll about anything you may wish to have discussed or may wish other people to discuss at our workshop tomorrow. So moving on to our first talk for today, I'd like to introduce Claire Drinkle, a Senior Curator Botanist from the Africa team at Kew.
Hello, thanks Alison. Right, so I'm going to talk to you today about conservation in the herbarium. And I'm going to talk about why we have the need for a conservator, the objectives in recruiting a conservator, the lessons that we learned, and the outcomes. So what is a conservator? And just to be clear and avoid any confusions, we're not talking about preventative biodiversity loss conservation. We're talking about conservation of collections. And I particularly like this definition. There's a few variations of this, but Carter and Walker, in their book Care and Conservation of Natural History Collections, says that conservation is really a twofold process. Firstly, it's about the controlling the environment to minimize the decay of materials. And secondly, their treatment to arrest decay and stabilize where possible against further deterioration. In the same book, there's a chapter, Vascular Plants, by David Bedford, and he mentions that dried plant specimens can be kept indefinitely as long as they are properly protected from insect, fungal and physical damage, but herbaria may have specimens in their own collections that have been poorly prepared, poorly stored, or have been damaged in some way. I think the may is probably more like most probably. So, why is herbarium conservation so important? Well, it's to ensure long-term preservation, of course, and also to enable access and use for research. It's also to minimize exposure to those people using the physical collection to residual insecticides or fungal spores, and presenting the best possible quality physical and online herbarium specimens. Kew Herbarium holds plant material collected mostly over a time span of 170 years, used extensively by global community of researchers. For example, annually 5,000 loans and samples are shipped out worldwide to researchers, and the herbarium clocks an impressive 3,000 researcher visitor days annually. The Kew Science Collections strategy outlines the need that all specimens and data are accessible, well curated and secure. The ongoing mass digitization project at Kew Herbarium is a once-in-a-lifetime moment in which each physical specimen is taken out of its folder and examined, albeit just for that snapshot moment during the barcoding and imaging process. During this process, there have been numerous issues found in the collections requiring skilled conservation work and skilled techniques for repairing and cleaning to stabilize materials. It seems right that the opportunity should be exploited to extract specimens requiring preventative or remedial conservation now. Those main issues are fairly typically found in botanical collections. For example, signs of insect damage, mold, stains or dirt, loose, deteriorated labels, specimens at risk, labels at risk of detachment, damaged or unsupported paper, non-archival materials present, pins attaching labels or specimens. All these issues and much more are listed in the newly updated Herbarium Handbook Conservation feature, which is written by Donna Young. She is the curator of the Herbarium at the National Museum of Liverpool in the UK. And this is a little plug. If you go to the QR code, that's where you can buy the book. And there's several authors in the room today, plus a couple of editors. I'm one of them. Okay. One additional issue specific to the digitisation project, or probably many digitisation projects, is barcode misplacement, as demonstrated by this specimen with upside-down barcodes. It seems like an easy task to attach a barcode to a sheet, but the truth is, imaging herbarium specimens is a highly skilled job. At Kew, digitisation officers are extracting, barcoding and photographing over 550 images per day. So some errors are going to be inevitable. And I'd like to take this moment to thank all the digitisers for their incredible patience and care of our collections. Trigger warning. These images I'm about to show you may cause some distress. Here we go. Mostly they've been extracted as a result of imaging the specimens. This is mercuric chloride staining on the sheet. Bit of insect damage. I think that might have been in Alison's slide earlier. This wasn't from the Digi project, but this is a bundle of pressed plants. It was not only the plants that were mouldy, the actual press and the straps were mouldy. Burnt, pretty bad. Shattered, I don't know how else to describe that one. There's lots of work for a conservator. Yeah, it goes on. But thankfully, these damaged specimens are the exception, and Kew Herbarium has beautiful herbarium material too. However, in a collection as large as Kew, the number of specimens needing specialist care soon began to mount up once the mass digitisation project began, hence the need for a professional conservator. Jana Kostelikova joined Kew 1 year into the digitisation project as a one-year contract conservator. She's an experienced paper and collections care conservator and worked in museums, historic houses and library collections, yet she had absolutely no experience of working specifically with herbaria. Our new conservator needed intensive training to understand the workings of a scientific collection and to adjust her working practices accordingly. For example, herbarium specimens, as you probably know, are constantly being handled and sometimes altered, such as new determination labels being added or samples being removed. Jana's brief was not only to safeguard the collection of damaged herbarium specimens, but also to allow their repeated, safe, and extensive use for future research. Jana is Kew's first conservator employed to work specifically with herbarium material. This new role involved a degree of investigation into priorities and appropriate needs for preventative and remedial conservation. This was done through gaining insights between departments such as the digitisation team, researchers and curators. Discussions with various stakeholders helped to resolve conflicting opinions. For example, whether to keep or remove the steel pins from sheets. We've had a lot of conversations about that. I still can't think what the answer is. By following the guidance and shared experience of herbarium users, plus following conservation standards of best practice, Jana has found a pragmatic approach to her work. Her work is very much just getting underway at Kew. As you can see here, a couple of examples of her work. This is before and after photos for redundant barcode removal and surface dust removal. And you've seen this picture again, but this is before and after of pest damage removal. And these images are forming part of working protocols for non-conservators to follow. The ongoing work involves numerous tasks in herbarium-related conservation. These include conducting experimental techniques for barcoding our most precious historic material. Also, consulting mycologists for the safe treatment of mold-infected specimens. She's creating working protocols for cleaning dust, pest, residue, and repairing damaged material, and the removal of the redundant barcodes. This conservation work is still very much work in progress. So, to summary, an unexpected and quite welcomed outcome of the Digi project prompted us to recruit a specialist conservator who was able to help us in the herbarium. But we did find a lack during the recruitment stage of conservators with a herbarium specialism, not only at Kew, but also perhaps at the wider herbarium community. So this meant that the one-year contract initially involved some intensive training for our new conservator to understand and prioritise the needs of the collections. Solutions came through discussions, sharing of learned experiences, combined with conservation standard guidance as to how she was going to conduct her work. The outcome will result in herbarium staff being better informed about appropriate conservation practices, with our conservator providing information, equipment, and instructions. Our biggest challenge, perhaps, is actually having a permanent conservator within the herbarium. The conservation in the herbarium will enable us to continue our commitment to high quality curation to ensure that our physical and digital resources retain their value for global research, as outlined in the Kew Science Collection Strategy. So just yet another plug for the workshop tomorrow in this room at 9 o'clock in the morning. What are your herbarium conservation concerns or priorities? Please come along and share your insights and ideas. Special thanks to Jana Kostelakova, Chloe Mills, the Bentham Moxon Trust for funding me to come here, and Shigeo, who's sitting here in the corner. Thank you. Also to all of our speakers this afternoon, and thank you for listening.
Thank you, Claire. We have a couple of minutes for questions, if anyone has any.
Hi. I was just wondering, you were saying there was some working out what your priorities for conservation are. If you haven't got the capacity at the moment, do you record some of the more minor ones that maybe don't need immediately addressing on the basis that in the future maybe you get the funding for it? So have you got that kind of record, if you can't address it during digitisation, that you could come back to it in the future?
So, as in some of the minor conservation work?
Yeah, I know with us, things like dirt on the specimen sheets is not something we would try and immediately address, but we would maybe want to address in the future.
Yeah, exactly. I think that's probably, like I say, it's still work in progress, so we will have a plan before the end of the one-year contract and work out those priorities. There's actually a lot of conservation work, very minor conservation work going on at the moment, with sort of the sheets that are torn or need minor repairs. That, they're getting done by the Digi senior creator botanists at the moment. So it's probably the bigger problems that we need the conservator to sort out the priorities for.
Is there time for one more? Oh, so a lot of us, we can't hire another person to take on a new role. So a lot of us are the conservator, but don't have the conservator background. Is there any way that Kew would be willing to, or somehow provide this kind of information for us as the people that are on the ground doing the work?
Yeah, that's 100% what we'd like the outcome to be. We definitely want it to be a shared experience, not just within Kew, but within the Herbarium community.
Any more time? Okay.
We have run out of time, but Claire is around afterwards.
Yep.
And tomorrow at the workshop, which you may have heard of, you might not.
I would have been done with advocate with my questions, so don't have to hear it.
Thank you, Claire. And our next speaker is Megan Toner, who's a museum specialist in the Department of Botany at the Smithsonian Institution.
Awesome. Good afternoon, everyone. Let's make sure the computer actually likes me. Today, technology has not been my friend. So, as a museum specialist, my goal is to preserve specimens for future use. So I want to conserve, keep everything together, put leaves into the fragment packets if they fall off. Researchers, on the other hand, want to destructively sample for their research, and we want to support that. But it also changes the specimens. This came to the forefront to us with this particular Asteraceae specimen that was sampled 3 different times by 3 different researchers in a 2-month time period. And they were not collaborators. It was just a very interesting specimen, probably because it's from Brazil. And right now it's very difficult to do field work in Brazil. With this in mind, our collection advisory committee decided to go through our destructive sampling policy and revise it. First, we wanted to see, has there been an increase in destructive sampling requests? Since 2010, I wasn't there at the time, but our staff has had people fill out forms, and as you can see, there has been an increase. Around 2015, we started a digitalization project, and our data has been being released since then. And as the herbarium has been digitized, the requests have gone up. The next question is, how big has the request been? Since 2018, I've been able to link the different sheets to the actual requests. And as you can see, there has been a drastic increase. The 2 times it hasn't was during the pandemic when none of us could go into the building, and 2024 when we have enacted our new policy. From this data, I can start to pull some interesting information. For example, the top 10 geographic regions that have been sampled since 2018. United States is the most, which to me is actually surprising since in the 1950s, a curator decided we weren't going to collect modern United States specimens. So all of these are historic. Brazil, Mexico makes sense because once again, it is sometimes difficult to go do field work in these areas. So students are coming to us to avoid the costs or because of the pandemic. These are the top 10 families that have been sampled. For us, it's Poaceae, Asteraceae, Fabaceae. We have had a curator in each of these areas. Unfortunately, now we only have a curator in Poaceae. So with this information, we reevaluated our form. The first huge change we did is now we're only allowing sampling in person. No loans, we're not going to sample for students. We don't have the staff to be able to sample. This also allows us to open a dialogue with visitors. So when they come, if their request is approved, we can talk to them, make sure they're sampling correctly, make sure they're sampling from the packets. And if they can't find the specimen they asked for, then we can suggest something else. We also have a bunch of rules. So no types, no sampling of species with 5 or fewer sheets, no specimens collected pre-1900, no endangered or extinct specimens. These 4 rules can be changed if a researcher comes with a compelling reason and they have the proof that yes, they are able to pull DNA and they are releasing it to the community, that they're just not hoarding the DNA information, that it is being released out there. The next 2 rules are right now non-negotiable. No National Cancer Institute. So in the United States, we have the National Health Institute through the federal government, and they went out to do anti-AIDS, anti-cancer research. While collecting, they had MOUs with the countries to prevent viral piracy. which means that these DNA samples cannot be released. Unfortunately, this is also very recent material from the 1990s with some very interesting areas. The other issue is for international visitors, no US sanctioned countries. Our Department of Treasury has sanctions against Iran, North Korea, Cuba, and we're not allowed to move those over the border without a lot of permitting issues. The Treasury consider these, even though they're scientific, as consumer goods. So this is a very complicated issue that we're running across, so we don't even want to touch this right now. We don't have the staff. We've also added an advisor addendum. So this is our destructive sampling form. If you'd like a copy, please email me. I'm more than happy to give this out. The most important parts are for the researcher to fill out. Here they can list the exact specimens they want. Since all of our sheets have been digitized, we like them to give us a rough draft. Once approved, and if they come, they can definitely change it. That's completely fine. We also have an advisor addendum for the students so that they can prove that, yes, they have the resources, the knowledge, and will be able to pull DNA. Since our goal is for one sheet to be sampled once and have that data out there. So if approved by our collection advisory committee, some are not, some are approved on a basis of us reviewing the specimens, I gather the following information from each visitor: barcode, catalog number, collector number. These I use to build the catalog, or the connection between the catalog record and our transaction module. We use Axial Emu as our database. So this is an example of a transaction. So here I list all the information that's needed from the student. The most important part is our items. These are each coming from the database. If we switch over to the database under transactions, you can see every single transaction this sheet has been involved in. Every loan, every destructive sampling. My hope is in the future we'll be able to have some kind of click box so that on the website you can see, yes, this has been sampled. You can go to GenBank, find what information you need. I then build a final invoice, and because we're the federal government, we love paper. So all of this is printed, everything is printed into a file. And these are sent down to our registrar's office so that in the future, if there's any questions, they can be accessed. So in conclusion, all these processes are still being fine-tuned. We realize that some specimens on loan have to be destructively sampled for identification, such as ferns. You need to look at the spores, so those need to be removed. Lichens need to have sometimes chemical analysis done. So we're going to have other parts for those. They've helped facilitate science while still protecting the specimens. We're trying to prevent people from sampling 5, 6, 7 times. We can start to pull data about what types of specimens are being sampled. In the future, we could build our collections there, like in Asteraceae, or maybe we need to build in other places because we don't have recent material. They're living documents. I have no doubt at some point we're going to need to change them, probably multiple times. And they're based on the needs of research versus the conservation of the specimens. I have no doubt that in the future there'll be new innovative ways to analyze these specimens that will also alter them, and we need to have room for those different techniques. There's also changing international and federal laws. As we move forward, there's things that will happen in Brazil. I know that they're starting to be more interested in where their specimens are going. Other countries are starting to do MTAs as well, like the Philippines. And also US federal laws are always changing as well. Now Fish and Wildlife is starting to get interested in plants, so we need to have room for those as different issues as well. Since hopefully these specimens can both last into the future as well as remain important tools for science. So, thank you.
Thank you, Megan. We have a couple of minutes for questions. We have lots of questions.
So I know that at HUH, we have some of the NCI aid specimens that were probably distributed. So this embargo on sampling, is that just for the collections you hold, or is it more of like, you don't want the DNA data getting out there, and then how will you deal with that for duplicates at other institutions?
So technically, NIH wasn't very clear, but none of them are supposed to be sampled, even if they exist in other collections. We just happen to be down the road from them, so we get more affected. So that's something I think we're going to need to work with them to make that more clear across all other herbaria.
Yeah, I'll mention it for sure. That's really interesting. Thank you.
Thank you. That was really interesting. I was just wondering if you could comment on what that decision about sampling only happening in person and people needing to visit. And to me, it seems like, well, that's going to disadvantage students who might not have the funds to travel, or people from other countries. So there just seems that there might be just an unfair advantage or disadvantage, really, to people who aren't going to have the funds to travel, and then perhaps parts of the world are going to have less botanical research from your collection because of it.
So first, we are starting to offer travel grants. We do offer travel grants to South American individuals who can come. Our biggest concern is a lot of times with the loans, when we would send those out, they were only being for destructive sampling, that international students were not interested in the morphological work. And that was our biggest concern. But we do understand that there is that concern about the other countries and being fair to everyone. So that is something we're also examining.
Great, thank you.
Do you have a standard annotation label that you apply to the specimens that have been sampled for DNA?
We actually do. I do send that out to students. They're more than welcome to use their own, but if they do not, or they've never sampled before, we do provide a standard form. I highly encourage them to do it ahead of time. They can even send it to me to print, and we do have blank ones available.
Just kind of commenting on the fact that people mail ordering of the specimens online, we were getting huge lists, like, I want 150 collections. And to be fair, you have to think about, we are stewards to our collections, and we must protect them, but we must also share the data. So it's kind of, you have to balance that. And one of the balances was you have to come in person, but we were getting huge lists of people just sitting. I call them armchair botanists. They sit, they have never gone into the field, they won't even go in the backyard to pull up a weed to sample it, and they expect all of this material just automatically to appear. And then they go through and they want the rare collections or the hard to get to collections, and we've recommended that possibly, if we can't give you the specimen, we try to recommend a herbarium in the country. Sometimes we recommend a botanist in an area that does field work that might be able to collect. I have done the same thing. I've done molecular work, and I've gotten in touch with people and said, I need this collection because I couldn't get there. So there are other options. We're not saying hard no. We're just saying, let's talk.
Thank you. Thank you, Megan. Thank you for such a thought-provoking talk. Our next two speakers are Victor Shields from Picture, Digitisation Project Manager, and Emily Manyagi, I hope I got that right, Herbarium Collection Manager at California Academy of Sciences Herbarium.
Good afternoon. Thank you very much for having us. How do I? advance these. Okay. I was already introduced. I'm Emily Manyagi, the collection manager in the Herbarium at the California Academy of Sciences. I've been there about 10 years off and on, and the last 4 years I've been the collection manager.
And I'm Victor Shields. I'm a project manager with Pictura. I've been working with herbarium collections for about 10 years and with Pictura for about 8. So before we begin, just to give you a little bit of structure to the talk that we'll have, there are a few things that we want to outline so you can kind of follow along until we get to the best practices part. We'll outline some goals of California Academy, how the project was made possible, and then the best practices after that.
So what are the goals at Cal Academy? Our mission, initiatives, and accessibility will be discussed in the following slides. Science, learning, and collaboration are at the core of the Academy's institutional mission. To make progress in these broad categories, the Academy sets out museum-wide initiative projects. These initiatives give clear thematic direction to staff, volunteers, donors, and various stakeholders who can tackle an important cause collectively. Recently, the Cal Academy introduced the Thriving California initiative, which highlights themes that are crucially important to maintaining biodiversity in California and beyond. Specifically, those include facilitating access to local nature, increasing the state's resilience to climate change, and regenerating biodiversity within the California Floristic Province, which is one of the world's biodiversity hotspots. Through this initiative, we are growing a statewide movement for nature through a wide variety of activities inside and outside our museum walls, including a new California exhibit titled California State of Nature, digitizing our plant specimens from California, and building an early warning system using community science observations to track coastal health and prioritize conservation efforts. Some of our specimen geocoordinates will be used to inform climate change modeling efforts through the initiative. As many of us in the museum community can relate to, the departments of our institution have a variety of needs and share limited resources. A major need that we continuously strive to address is improved access to the array of specimens in our collections. Now, more than at any other time, massive data sets from these collections are being used to approach ecological and societal research questions that have the power to impact policy and the future of biodiversity. Mass digitization is one action that can help remove major barriers that limit accessibility to specimens and their data. So how did we make this project possible at the Academy? Our digitization efforts began in the 1980s. We began databasing specimens electronically, and in 2008, we made the first images of our dried plants. At the time, the initial impact to research being done at the Academy was small. But in 2009, CAS took part in the Mellon Foundation's JSTOR project to digitize type specimens, and since then has continued in-house imaging, proudly achieving over 100,000 images and 700,000 fully transcribed labels by 2023. However, at the rate we were going, it would have taken up to 5 decades to digitize our entire herbarium. With more than 2.3 million sheets and packets in our cabinets, we needed a faster way to make our data available. Thank you, Victor. So in 2019, my colleagues and I reached out to Pictura after visiting their booth at the Chicago Spinach meeting to learn more about the digitization methods they had used with institutions like Naturalis Biodiversity Center in Leiden, Netherlands, and the Smithsonian National Museum of Natural History in Washington, D.C., United States. There they used conveyor belts to image and transcribe millions of specimens in several months or a few short years. We wanted to know if this method was possible for our institution. And it was, with the right help. So at Cal Academy, we are fortunate to have cultivated a scientific community that philanthropic organizations and individuals have been interested in funding. Each year, we hold a gala that highlights our institutional initiatives to showcase why these causes are important. And the big bang there was last year's gala flyer. The Moore Foundation has generously supported our nonprofit institution for more than 20 years and was proud to contribute funding to make the digitization of all our California and North American plants, up to 1 million specimens, possible. We recognize this funding source as crucial to having allowed the project to move forward. As an institution with many departments that share funding, it was also essential for our project, limited to the botany department, to be supported by all museum sections, including marketing, outreach, and upper administrators. Alongside botany, multiple complementing projects are ongoing in our entomology and geology departments to achieve a similar goal of making specimens collected from California generally accessible to the public and to researchers at large. Getting leadership support across our complex organization was a major factor in making the project happen.
So now that you've heard a few of the origins of digitization at Cal Academy, we wanted to put together some of the best practices that stood out to us. So we're going to be focusing on preparing specimens for digitization and also imaging the collection itself. So in regards to selecting specimens for digitization, we recommend to digitize parts of a collection that primarily fulfill a specific institutional need, and thereafter build upon that core theme to digitize as much of the total collection as possible. So in your collection, you might find it both simple and difficult to select a portion you want to digitize. While it's usually easiest to digitize a collection from one end to another, that's not always an option based on time, funding, or other important considerations like material format and specimen condition. At Cal Academy, the collection is organized taxonomically and geographically inside folders. The funding for this project prioritized the digitization of all California plant specimens. To meet this requirement, all folders labeled California were selected for preparation. Funding that remained after this group was completed was then directed to digitize North American specimens. Regarding barcoding the selected objects for digitization, we recommend identifying the layers of your collection that can be recorded during digitization so that the resulting digital collection is most logically organized. This step ensures immediate familiarity with the materials in your collection. So herbarium collections can be stored inside boxes and folders. They can be kept loose in cabinets and some other way in between. So when creating a digital collection, recording consistent organizational elements like these can be very helpful. For example, Pictura often digitizes herbarium folders to record a filed as taxonomic name. With this method, we can record each specimen's physical location within a folder, box, or cabinet. This step ensures the formation of a data hierarchy that initially organizes your digital collection in a familiar way. Associated metadata, like specimen label data, can be attached to one or more of these levels. So, going the imaging route with mass digitization, we recommend creating a standardized digitization workflow that maximizes efficiency and prioritizes repeatable quality. Ideally, at least 80% of your collection can be imaged this way. Over the last 2 decades, hundreds of herbaria have made significant progress imaging their collections. For many universities and research centers, only a finite number of working hours per week or month can be budgeted for digitization. Looking at the time it could take to process an entire collection under these conditions ranges from months to years to decades. Mass digitization could be a great solution for rapidly transforming your collection for virtual access. Creating such a workflow requires an imaging protocol that can accommodate a majority of the specimens in the collection, one that will vary as little as possible from one specimen to another. When this standard is defined, a consistent way of working will be used to achieve a maximum throughput, and suddenly an endeavor that could have taken 10 years can now take 1. And finally, in terms of project strategy, we recommend identifying a workflow that balances the day-to-day workplace duties of institutional staff with the responsibilities to the project itself. Reserve some of your energy for outreach. So to digitize the Academy's herbarium, we decided to use a conveyor operated by 2 Pictura staff who together can achieve an average of 4,000 images per day. Next to our employees, 2 on-site staff members were hired by Cal Academy to barcode all the selected specimens and folders, as well as to transfer those specimens to and from collection storage. During digitization, we look for ways to limit our overall footprint within an active herbarium. Of course, several other staff members contribute to the project both from Pictura and Cal Academy, but as those employees already have a list of responsibilities that existed prior to the project, it's crucial to consider how much time and resource is required to successfully complete the project. These decisions have an impact on the overall imaging throughput speed and total project cost. And we know that it's very important to involve several different people in the process of digitization. But yes, this is some of the consideration that we felt was interesting to share with all of you. And one bonus recommendation, we think you should ask for advice from others who have performed similar digitization projects. In my experience, everyone is always very happy to talk about that with anyone. I think you can relate, Emily. So we'd like to thank Spnhc and Tdwg for having us, all of the team that we've had digitizing the collections, doing all of the work. So thank you.
Thank you. Do we have any questions? Thanks again. We have just a couple of minutes, so we'll just catch up with the timing. We just have a quick comment online. Sorry to interrupt. We have a quick comment online that we've just seen. Proud to say we had Pictura with us for 2 years to digitize our 1.2 million herbarium, and that's from CSIRO. I guess that one's for you. It is Nicole. Thank you for that. Okay, I think we're ready to start our next presentation now. I'd like to welcome back our speaker, Atsuko Takano, who's the Herbarium Curator at the Museum of Natural and Human Activities, Hyogo, and Professor at the Institute of Natural and Environmental Sciences at the University of Hyogo.
Thank you for introduction. Again, hello, Takano here again. And this time I want to introduce you the system we developed recently. Everybody here knows what the herbaria are expected to digitize their collections and open to the web. However, as a curator of a museum, I know how tedious work and difficult the work and organizing specimens can be. We mount specimens and labels and barcodes and IDs on a herbarium sheet and enter the label information and ID into a database. If you are a curator, you may say that's impossible to begin digitize in addition to a specimen arrangement. But digitizing specimen and provide images on the web has various advantages, not only for specimen users, but also for us curators who organize specimens. Oops. Okay. So we devised a method for automatically extracting specimen level information from specimen images using optical character recognition, OCR, and named entity recognition, NER. And it's an application that can be used on a standard PC. Unfortunately, this system is specialized in extracting specimen level information from Japanese specimens. I'm sorry, but I think it's possible to develop similar system for any countries for a similar way we took. This is a system aiming for extracting level data of plant specimens, but when we tried specimen images of birds or shells in which the specimen level and the specimen appear together in the images, as in the case of plant specimens, we were also able to successfully extract level information. So we decided to open this system on the web. This is the URL and barcode, ID and password. So I'm not, sorry, again, this is developed for Japanese specimens. No, not so sure what happened if you tried in specimens from abroad. Anyway, let's try and please let us know if you tried and what happened. Then, next, this is a scheme of a system. So each local museum prepares image of specimens, log into the system, and upload the specimen image to the cloud server. And the system compressed and saved the images, and also at the same time sent to Google API. And then text extracted by OCR, then labeled by NER, named entity recognition using Spnhc, trained for Japanese. Then, for example, plant names and locations, the collection dates, they put the label. Then they are compiled into a database and saved in the form of a CSV file. Each local museum can download it and store it in the specimen database in local museum. And this is the screenshot of upload image files. You can upload multiple files at one time. Then, when upload specimen images, the OCR button is appeared on the upper left, and when you push this button, OCR analysis is started. Then after text extraction from all images is done, then leveling button is appeared. Then when you push this button, they start leveling text using natural entity recognition. The labeled text here is automatically identified where should be in and moved to the appropriate date fields. If the labeling is incorrect or there are multiple data suggestions, you can correct, modify, or select them on this system. Then data arrangement was done. You can select and download data using this button. This is a CSV export button and as CSV format file. Oh. Then this system was originally trained to read the herbarium levels of our museum, but some museums are now using it as it is. Then others have started to setting it up for their own museums. So whether it can be applied to overseas specimens is unknown, but I think we can build an automatic reading system for local specimens in the same way as we did. We hope to use this system to make it to enter specimen information, which will eventually promote specimen digitization. Then finally, the funding, we acknowledge the funding, and I'm good at writing English better than speaking. So please, if you are interested in the method, please read this reference. Thank you for listening.
Thank you. Do we have any questions?
I'm wondering if all of the labels are typed or if there are any that are handwritten.
Yeah, that's what I frequently ask the questions. Our museum is still young, so most of our collections levels are typed, so it's easy to read by OCR. But nowadays, OCR technique is much improved year by year. Then, so if the handwriting, they are written by block letter, and it's very nicely arranged. The OCR can be read, but if the character has like this, it's rather difficult.
Thank you.
Yes, wait a minute. I just was thinking about something else, I forgot. When it's OCR, when it's going through your labels, are you checking for correctness with each individual that goes through, or are you batching the information? And if you are doing it in multiples, who's checking the data before it goes into your database?
In our museum, not myself, one of the mounters who knows much about taxonomy and label information. Hi. Yes.
Takano-san, so you mentioned this system works for Japanese entries, right? What about like things written in Mandarin, for example? So things from Formosa or from China, does it work for them as well? No.
We never tried it, so please try.
Yeah, yeah.
What happens?
I want to try it.
Yeah.
We can talk about it later, but yes.
Okay. Thank you.
Okay.
Okay, 15 minutes. Ready?
I did have just one quick question for you.
Okay.
What advice would you give to herbaria outside of Japan if they wanted to start this process?
Yeah. We just opened this system in last February. So not so many museums know this system. So we want to publicize this system to all the museum, the natural history museum in Japan. Yeah.
And outside of Japan, do you think it would work to in other herbaria, in European languages and English and Thai and?
Yeah.
Do you think it could be adapted?
To apply our system into the other countries, then we need to train our system for their own. For example, English. So you need to English training, and also we need to prepare the scientific name dictionary or geological dictionary behind the system. It's much better, and it's faster. Make it faster and more precise information they can extract and put labeling. Yeah.
Thank you.
Find the programmer to train this, please.
Thank you again.
Thank you.
And again, we just have a few more minutes before we'll start the final talk. Thank you. Next speaker is Hannah Merchant, and as it says on the screen, she's curatorial assistant at Harvard University Herbaria.
I can get started? Okay, great. I hope you're not all tired of hearing about digitizing workflows. There's going to be some slides that look really similar to other slides you've already seen, but just bear with me. So yeah, I'm Hannah. I'm from the I'm a curatorial assistant at Harvard University Herbaria in Cambridge, Mass, US. And I'm going to talk about our current workflow for digitizing our large collection of vascular plants. Just a little bit of background, we're called the Herbaria, not the Herbarium, because we hold 6 distinct collections within the building, so we have 6 different acronyms that apply to our collections. HUH is not an official acronym. We have over 5 million specimens across those collections. Most of them are vascular, around 4 million are vascular. So those are almost entirely pressed and mounted on sheets and stored flat in folders. And our collections are global in scope, and they're still growing, but they're particularly strong from the Americas and from Asia, and especially from the mid-1800s. So there are challenges that come along with having an older skewing collection like we do. Many specimens have handwritten labels that may be fading or just hard to decipher. Sometimes multiple specimens are mounted on the same sheet to save paper. Older glue may start to disintegrate and acidic paper can become yellow and brittle. And these are all curatorial concerns that inform decisions we make about digitization. So you all know what digitization is, but when I say that, I'm talking about capturing the image of a specimen and entering data about its identification and collection event into our local database. We use a very heavily modded version of Spnhc, so it's a lot different from Spnhc and how even normal Spnhc looks. So obviously herbarium specimens hold a lot of important scientific information, especially older specimens, which can help paint a picture of what the natural world looked like when they were collected. Getting specimens digitized has many benefits. Specimens might not need to be physically handled as much when images are online. And data from multiple institutions can be aggregated to uncover climate change and biodiversity loss trends on a larger scale. So at HUH, we participate in several collaborative digitization projects that are often grant funded. Our general curatorial staff, like me, who do a lot of things, but we digitize 1 day a week. And then we also have 8 full-time digitizers on staff. Okay, I've seen this exact image already. So we've been through several imaging setups over the past 2 decades, and I've worked on basically all of these. I started as a digitizer for GPI, so I just was scanning types day in and day out. So I still do that sometimes, and it's fun. So some of these are still used for specific purposes, but they were not ideal for our large-scale digitizing. So we use the inverted scanner for creating the very high-resolution images of vascular type specimens for uploading to JSTOR. And each scan takes about 5 minutes, so it's just not practical for mass digitizing. We use a camera mounted on a copy stand for many of the cryptogamic TCNs, but this workflow requires a lot of manual editing and cropping of images because they're packets that are pinned onto sheets. We use this modified jewelry light box for imaging macroalgae specimens, which is also quite slow. It involves opening and shutting the box for each image, and our macroalgae are stored in polypropylene sleeves, so you have to remove it from the sleeve to reduce the glare. And then we had a conveyor belt set up on site for the NEVP, the New England Vascular Plant TCN. This format required 2 operators working in tandem, so if one person was absent one day, it would kind of slow down the entire procedure. So it just wasn't practical for a lot of reasons. Our current digitizing setup is what we called a photo station. This was designed and fabricated in-house and has been in use since about 2018. We have 5 of these photo stations in use now. And I'll link a publication in the final slide with the exact specifications for this setup, but it consists of a Canon camera hooked up to a Mac Mini, mounted above an adjustable height platform with staging areas for specimens and a large shutter button to operate the camera. There are 4 main steps to our current digitizing workflow. Digitizers will select one plant family to work through at a time and then go through these 4 steps in order: taxon checking and barcoding, imaging, image post-processing, and transcription. This is from Okinawa. I found it was already digitized in our database. Okay, so the first step is checking the taxonomic validity for each species name we encounter in the selected family. We want to make sure that we're only using validly published, accepted, and legitimate plant names. If the taxon is not already in Specify, we will manually enter it during this step. We consult several online botanical resources to check the names, and if necessary, if the publication is not online, we'll also go look at physical resources in our botany libraries, which is on site. Specimens are given a quick visual check to make sure they have a stamp from one of our 6 herbaria, and to determine whether the specimen needs repairs before being safely digitized. We also check the specimen to see if there is insect frass or damage that may indicate a pest problem in that area of the collections. So a barcode sticker is placed on each specimen, and when there is more than one specimen mounted on a sheet, each one will get its own barcode placed near the collecting label. And as we work through a folder and each sheet is barcoded, we restack them in reverse order handling the specimens carefully and not flipping them upside down. And then they're ready to be imaged. So at the beginning of each imaging session, the operator will check the camera's focus and make sure that it's level. The first image of each session will be a large color checker that's used for correction during post-processing. And then we take an image of the folder the specimens are stored in each time there is a different taxon name. The order of images is preserved when a transcription batch is generated, so the folder images show us which taxon name the following specimens should be digitized with as their filed under name. The sheets to image are placed on a holding, oh shoot, I wanted to click, okay. All right, this is the holding shelf. The sheets to image are placed on this shelf. They're moved one at a time to this photo stage. A large red button on the side of the frame is then pressed to take the photograph. And then imaged specimens move to a pile under the holding shelf, and this process restores the original filing order of the sheets in the folder. And we can move through a stack of specimens very quickly. It's about 8 seconds on average per specimen, sometimes even faster. Okay, so bioinformatics staff completes the post-processing steps to create batches of images for transcription. Several images from each session will be visually checked for focus and alignment. Image corrections are applied to the batch, like setting curves, white balance, and adjusting light fall-off. Then derivative files are generated, so that's archival DNGs, web-friendly and full-quality JPEGs, and thumbnails. The images are then ingested into our database. We use a software called zbarcode to read the barcode number, linking it to the records, and then creating a batch for transcription. Our transcription application is web-based and was also designed in-house. When we first log into this app, a drop-down list of batches appears with the digitizer's name, and you pick your own, obviously. Selecting a batch opens up 2 browser windows. One is a mostly blank transcription form with an image thumbnail, and the second is a zoomed-in view of the specimen image. And anywhere you click on the thumbnail will appear larger in the second window, so this is used for getting a closer look at the label or any other relevant parts of the sheet. We manually enter the collection data from the specimen label into the relevant fields in the blank form. Most of the fields are free text, but some are lookup fields that pull from data already in Spesify, so that's taxon name, collectors, and higher geography. If the collector name or names on the label don't show up in the drop-down menu, they will need to be carefully researched and entered into the botanist form in Spesify. This also can slow us down significantly if there's like a team of collectors and it's not in quite the right order, if one team member is missing. So that is a bottleneck that we deal with. The fields that are captured for each specimen depends on which project they're being transcribed for. We are overall trending towards capturing fewer fields in order to increase the speed of output, but some projects do require that all of the information on the sheet is transcribed. And after transcription of one record is completed, there's a save button at the bottom, which sends the data into Spesify and links it with the image. We repeat the process by clicking the next button. Each time you click next, the filed under and current name, the taxa will carry over. So you just change that when there is a folder image that indicates a new taxon. And then at the end of the batch, you will have the option to click the done button. Once the record is saved, it should immediately show up in Spesify and on the digital collections part of our website. The data appears in different formats. So in Spesify, it's spread across 3 tabs or modules, and on the website, it is all condensed into a list. And unfortunately, our version of Spesify does not accommodate specimen images, but they do show up on the website when you search for a barcode. Our data also goes out to online portals for the relevant digitization project. We use IPT software to publish our data as Darwin Core, and our feeds are updated weekly. But GBIF and the portals may pull it less frequently, so specimens that are entered or edited locally won't immediately sync up with online data in external resources. But the end result of this process is that our specimen data is viewable to the public in many different places online, and we're able to be contacted with any comments or corrections about the specimen data. So this digitization workflow has really ramped up our speed in making our collections data public. We're currently at about 30% of our collections digitized, so around 2 million. Some minimal, some full, or type specimens are fully data captured. And someday we'll get to 100%, hopefully. And the benefits of this workflow go beyond disseminating data. Transcribing directly from the images decreases the amount of times specimens need to be handled. And with such a historic collection like ours, that is crucial. This has also opened the door for remote work. That was handy during lockdown in 2020, and today it allows for more flexibility in the work week. The process is still evolving though, so we always look for ways to increase efficiency. This year, we've been experimenting with ingesting taxon names from GBIF and checking the initial step of checking the names. I will say the results have been mixed. Eliminating one step we've found has the potential to create a greater amount of work down the line. And unfortunately, this workflow doesn't yet accommodate our cryptogamic specimens, which are curated differently. And we hope someday we can ramp up digitization on this scale for the cryptogams as well. Okay, thank you so much for your attention. I'm happy to answer any questions. And as I mentioned, this article has the exact specifications for our photo station if anyone's looking to build one. Arigato gozaimasu.
Thank you. Do we have any questions?
So we're struggling in our institution with an institutional dams being possibly installed. Third try, we'll see if it works. So I'm guessing, and perhaps you can tell us, when you take these images, where do they go? And how do they find a repository that then makes them available to the world?
We have a research computing, I'm not the computer person, so I'm not going to use the right words, but we call it RC. There is like a large amount of storage. I think we have images on RC and also Amazon Web Services. I'm not sure if that's still in existence, but they go to Western Massachusetts, basically. Yeah.
I have a question. Have you thought about updates to the digital collection once you've hopefully finished the whole project?
Update, like making changes?
Yeah. Will you look for something like a new role of a digital curator, or would that be down to the current curator's role?
We just have general curatorial staff that makes the changes as needed. I personally monitor the portals where our data is, and we get a lot of comments like, oh, this identification is wrong, it doesn't match what's on the label. The geographical, the Latin long were reversed, so I personally will go and edit those in the collections kind of on a case-by-case basis and see if the specimen itself needs to be updated, re-imaged, and maybe even moved to a different like geography or taxon. Mm-hmm.
Any other questions?
Do you have any problems with manpower to do the digitization?
With manpower?
Yeah.
Ideally, we'd have like 3 times as many staff. Being part of an institution, we are just at the whims of how much money is given to us to hire. We probably could accommodate physically a few more staff members. We just don't necessarily have the means for it. But it would be great if we could hire more people. Okay. When's that? Tomorrow, 10 o'clock. Great.
And we've got time for another quick question if anyone has one.
I'd make a plug about. So Simone asked about image serving, and so I'm at Rutgers University. I don't know if you're at a university, but we contacted our IT department, and they gave us NAS servers that they were able to refurbish from other departments, and we host our own images. So I can get you in contact with our IT person, or your IT and our IT. Come find me. We can talk. Yeah, we do that too.
Thank you.
Thanks.
And thanks again, Hannah. And welcome to our final speaker this afternoon is Frank Owen from Max Communications.
Hi, I'm Frank from Max. Can you hear me? Yeah, all right. We're a digitisation company, been going for about 25 years. We've been working for the last 23 years on archiving heritage projects. So for us, Q's like our first move into the life sciences. We've used some of the lessons that we've learned from doing heritage projects with the life sciences. There's a lot of lessons that are learned that are similar. So these are the drivers, obviously, for it. We're doing Q at the moment. There's got 7.5 million specimens or 8.5 million images, I think. But there are 491, last time I looked, 491 million occurrences on GBIF, which in the Herbarium, which all need digitising, I presume. And we need that, making these occurrence maps, you can see what grows where, when. These are the big drivers. So the key question is, what's the fastest and most accurate way to extract metadata from herbarium specimens? There is some academic research on this, which kind of matches what we've been doing in practice over the years. So there's these MIDs, the minimum information for digital specimens, and also this thing from Hedrix about these two different stages. So basically, it says capture your images with a unique ID, and then afterwards extract the metadata, and then the third stage is doing a crowdsourced enriched metadata. I saw Dean the other day. Actually, in some cases, it's better to just to do it at the point of putting in your metadata. But that's some cases where we've difficult to capture material. What I was talking about is about how we capture the inherent structure of an archive or a life science collection while we're digitising during the digitisation process. So here's another one of those flow diagrams, not as pretty as some of the other ones I've seen today. The system that we use, we've got like a decentralized system like you were showing at Harvard. So we've got like photo stations. We've got about 40 in Q. It's quite a big one. We expand and do it. So there's individual capture stations, and then we've got a server which at Q is actually in their data center, but which got a relational database. And so for the bigger projects that we do, we make a relational database that mirrors the structure of the archive. So how the archive's structured is how we make the relational database. At Q, that's down to families, and then genre, and then GA folders, we call them genus area folders, and inside those are species folders, which I'll show you at the moment. So the process starts with what's already there, what exists already, and it starts with the curator. And as Alison was showing us earlier, I think, Nina, I can't remember, but you have big lists of what you've got. You've mapped out the material, and that gets passed to us. We put it into the relational database, which we make the genre inside. We've got a table of genre, which is hierarchical with the species, etc. We have a little script which makes a load of folders which capturers download to their local machines for whatever area they're in. So wing B, first floor, these are the families, and inside there's the genera, there they are. And then our capturers capture per box inside there, and we've got like a keypad where they press different keys for different types of things that, objects, the different folders that they capture. And I'll just show that in a little bit more depth. So like, here's the spreadsheet that the curators have produced, or whatever it is. Put that in a relational database, make a set of folders that the capturers use to capture into. And there's the hotkeys. You press the hotkey, and you see the file names that are exported out. We use a Capture One software, and we export out a high-resolution TIFF, which is like the preservation copy, and a JPEG, which we use for doing the transcriptions for. We capture all the folders, so you can use them for transcription only. They're only used for transcription. The actual specimen cards are what goes into EarthCape at the top. As you see that in the name there, because there's some of these have already got barcodes on them, they've got at the beginning of them, they've got like a thing to keep it in order. Like you were saying at Harvard, you have them in order. And then we have like a label red for brown, because that's the only colours that they had, just annoyingly. A blue for the white folders, and then none for the other ones. And we have I think we use purple for supplementary pictures, where we've got suffix pictures, like more than one picture of the same specimen. Then we have a script, which, as I say, runs, when they've finished doing a few boxes, they press a button and it registers them all on the database, and it makes a script so that overnight it uploads from the client machines and puts them into a nice ordered list with like taxonomically ordered, like that. We have the different names for the species folders that are doing that, like that one with SP, and the GA folders, those brown folders. So once it's in that, we have a front end on it, which we call Themis, which we use specifically for project management of digitisation projects, and for also doing the metadata harvesting. And then we export out from this once we've got that, it's all based on that relational database. And once we've transcribed it, or it's all been transcribed and gone through a set of QA processes, where, keep track of all the states and everything, then it gets delivered into Earthcape. The first step is to transcribe the folders. So as I say, each folder's got a unique ID, and it's also got so there's a brown folder, there's the species folder, there's the specimens that are inside it. And when they transcribe this, because we've already got the folder that they've captured into the genus folder that it's in, it already says what genus it is here already. And they have to pick from a drop-down list of authority lists, which again supplied by Q, about which particular region it's from. So presumably not all herbarium have got the same structure, but so you can see that whatever your herbarium is, you can do something similar to this with a little bit of wangling around. There's the list. And then they transcribe the species folder, so he knows what genus it's in. We've got a type ahead thing here, and we're using an authority list from the WCVP. Other authority lists are available, I understand. And then when they've picked one from there, that automatically leaves that hierarchically trickles down to the individual specimens. And so there you see at the top there, it's got which one it is. We try and open on where the label is on the page, and it's got like a zoom on it. I quite like your thing that you've got at Harvard where you click on it and it does that. We may have a look at putting some of that in there. We've got like an audit history, so everybody logs on. When you log on, it audits all the things that you've done, so you can see what's been done to it, when they've done it, who's passed it, etc. We've got a demo if you want to have a look at it on the thing. Again, we've got other authority lists with the collectors, which you got from HUH. I don't know if you're familiar with them. And the country list we use is the ISO 86611 on here. There are some other projects we do for archival things. We use the historical ones as well, because it gets a bit tricky when you've got the Soviet Union and things. Those ones are always a bit tricky. And it also pops up which, the states that are in there. And obviously there's none of these is a crucial one. None of the above. These are the ones that I know about. I'm more than happy to hear if there's more of them. The one at the bottom is the crucial one here, institutional authority lists. So we've done a smaller herbarium at Guernsey, where we were working at Guernsey, and they were using Kent numbers. Anyone ever heard of them? Yeah, and they also had a list of Guernsey names for flowers as well. So we put those, and we know that there's a lot of institutions know what collectors they've got, and so you can have a shorter list on the collectors. Well, the orange light's gone, so I'll just have a quick tells about what we've been doing on AI. We've been using AI across the different projects. Inevitably, it's really good, and then it just goes a bit mad. Like in the film RoboCop, I don't know if you've seen in the beginning of that, where it goes and shoots everyone. That's definitely going to happen. This example here, we were doing, it was like a 1560s Hebrew and Gothic German it was translating, and it did about 700 pages fine, and then started doing it in Korean. Just. So when we've been experimenting with it at the moment, and what we do is it obviously needs a human in the loop. And so when we run stuff through, we give it as options that you can click on and add it on, but it still needs like QA and totally all the way through, if not like more transcription. We've been trying with the geocoding, which I know is like one of the crucial things about where things are growing. Sometimes it's great. This particular example I got here is one that's in Argentina, and it's looking for Camino a Palmasola, which is the roads to Palmasola. And it's got it kind of right, it's in the right region, but it's put it in this town here, and it's actually found a street called Palmasola. So we've tried doing, we've added on some bits for like using geolocation gazettes, like Google Maps basically. So they can put it in there and it'll find it exactly. But then there's Palmasola, but then again, the thing is that it's the Camino a Palmasola, it's the road too. So this, which we need to look at, is as we're saying in that first thing about those mids 1, 2 and 3, this is about mids 3. You need to have like some way that you can get local knowledge to get people to go and say, well, whereabouts is this? I mean, the ones in Guernsey, it's like the car park behind the pub, there's things like that we're getting. These are the key principles we've got. It's easier to harvest data post-digitisation unless you've got some wet samples which have got really difficult labels to get to there on it, as Dean pointed out. Using existing catalogues that are already there, contextualise the data and make the metadata harvesting faster. All digitisation projects are audits. So, there is a case for just capturing all of the metadata verbatim, particularly if you use an OCR for it. I know that there's a field in Darwin Core for that, but it'd be nice to have something where it's just raw, what the OCR's pulled out, even if that's not correct, so you can just do it quickly and get it in there. And for us, this one here, I see in American collections, it's all done by theme. It's definitely more inefficient if you don't just do the lot. If you're picking and choosing, then that makes, like we see if we have to do recaptures, heaven forbid, but if we have to, they take 10 times as long. And I see that in American collections, they get done by theme, and it's taking it off the shelf and pointing it in front of the camera is where the overhead is now. And if you have to do it bit by bit, that's much, much more inefficient. That means I've finished. I've put in citations. I'm not really up on doing this sort of. Thank you. That was it.
We have time for maybe one question, if anyone's got anything burning they want to ask.
Hi, I'm Siobhan Wikidatan. Are you going to be using...
Put it on Wikidata?
Yeah. No, I'm wondering about the Harvard Index of Botanists, which I adore and I work on every single day, but it's not complete in any respect. Harvard Index of Botanists, which you're using for collectors?
Yeah. So if it's not on there, they've got an option for verbatim. So you can put it in verbatim.
Okay. Which is, okay. Have you considered using other data sets?
Yes, totally. So we, as I say, we're a digitisation company working for Q.
Yeah.
And as I say, if there's other data sets you want to use, then we
try Wikidata. I've been spending 5, 6, 7 years doing this.
Say that again.
Wikidata. Use Wikidata. Yeah. There are heaps of people in this room who've been doing it as well for multiple different institutions, countries, etc.
Siobhan, I refer you to Q.
Okay.
I totally take on board what you say, and we particularly want to do like smaller herbarium and be able to do stuff as well as the bigger ones. And if they haven't got those resources to know what it is, and we're more than happy to go and have a look at Wikidata. I hear what you're saying. The Wikidata projects we have done have been in the archive world. So for like Lloyd's Register and things like that, that's all gone into Wikidata. Yeah.
Thank you, Frank.
Can I go now?
Go. Thanks for everyone for your...
I wanted to make just one comment about the Harvard Botanist database, and I love they're using it. and not to cut down my own employer, but there is definitely inconsistencies there, especially from our New England vascular plant project. We had a free text field where botanists could be entered, and there were a lot of typos and just incomplete, like just misreadings of the labels. So it's not perfect.
There are, like you say, lots of different versions.
Yeah, yeah.
So it's quite good because that means that they can get it verbatim. They have got like a reference.
Yeah, yeah, and I'm working to clean it up. It's an enormous task, but I appreciate knowing that it's being used widely. Thank you.
Well, thanks everyone for your questions and discussions today, and thanks again to all our speakers. See you tomorrow.